What is up, my chemistry people? Who is ready for a thriller of a free response? The atomic number and corresponding atomic radius of the period 3 elements are shown in the data table below. Boom! Part A. On the grid above, mark an appropriate scale on the axis labeled atomic radius, picometers. Alright, as I look at my atomic radii here, there's not really a right or wrong answer here. We just want to make sure that we're able to graph each and every one of these atomic radii. I'm going to start at 0, and every line is going to represent 10 picometers. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Boom! 1 point just for making a scale. I love this free response already. Part B. On the grid above, plot the data from the data table. Circle and connect the points. Easy. 11, 160. 12, 140. 13, 124. 14, 114. 15, 109. 16, 104. 17, 100. 18, 101. Circle, 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 circle. Connect. Boom! 1 point. Part C. Explain why the radius of sodium is larger than the radius of argon. Alright, anytime that you're answering questions about periodic trends, it's important that you mention 1, main energy level, and 2, the effective nuclear charge for each thing that you're comparing. Sodium has 3 main energy levels and an effective nuclear charge of +1. Argon has 3 main energy levels and an effective nuclear charge of +8. Scope them out on your periodic table. Sodium, boom. Argon, double boom. As we think about our explanation, same number of main energy levels, so it must come down to the effective nuclear charge to explain why the radius of argon is smaller than the radius of sodium. The two elements have the same number of main energy levels. However, the smaller effective core charge of sodium indicates a smaller attraction for its valence level electrons, and therefore a larger radius. Boom! Listed main energy levels, effective core charge, and explained why the radius of sodium is larger than the radius of argon. All comes back Coulomb's law. Part D. Explain why the radius of sodium is larger than the radius of lithium. Sodium has 3 main energy levels and a effective nuclear charge of +1. Lithium has 2 main energy levels and a effective nuclear charge of +1. Now we're comparing sodium to lithium. Boom! Find them on your periodic table. Remember that the rows or the periods tell you the number of main energy levels and the group tells you the effective core charge. In this case, the effective core charges are the same, so it must be the number of energy levels that explains the difference in their radii. The two elements have the same effective nuclear charge. However, the greater number of main energy levels in sodium increases the shielding of its valence electrons and therefore gives it a larger radius. Boom! Listed out main energy levels and effective core charge for each element and then explained in those terms why the radius of sodium is larger than the radius of lithium. Part E. Explain the change in radius when a sodium atom becomes a sodium ion. A sodium atom has 3 main energy levels, and its valence electrons are attracted by an effective nuclear charge of +1. When a sodium atom becomes a sodium ion, it loses its valence electron and a main energy level. The resulting sodium ion has two main energy levels, and its valence electrons are attracted by an effective nuclear charge of +9. Woo! Attractive. As a result, when the sodium atom becomes a sodium ion, the radius decreases. Boom! Once again, think about each thing that you're talking about in terms of main energy levels and effective core charge. Use those two things to explain any and all trends. All right, let me bust out my amazing art skills to help clarify what's going on in this question. A neutral atom of sodium has 11 protons in its nucleus. It has 3 main energy levels. The first level has 2 electrons. The second level has 8. 4, 5, 6, 7, 8. And its valence level has 1. When it becomes the sodium ion, what has happened, it has lost this electron and essentially that entire energy level, because that was the only thing hanging out in that level. So now, as you think about the core and its effective pull on its now second level valence electrons, these electrons are feeling a pull of +9, a far more attractive pull than that valence electron did in the neutral atom of sodium. Boom! Art skills for the win. Part F. Explain the change in radius when a chlorine atom becomes a chloride ion. A chlorine atom has 17 protons, 3 main energy levels, and its valence electrons are attracted by an effective nuclear charge of +7. When a chlorine atom becomes a chloride ion, it gains an extra electron. The resulting chloride ion has the same number of protons, main energy levels, and effective nuclear charge as the neutral chloride atom. However, the added electron increases the electron repulsion. As a result, when a chlorine atom becomes a chloride ion, the radius increases. All right, this one's a little trickier to do, but my art skills are really good. Chlorine neutral atom, 17 positive protons in its nucleus. 3 main energy levels. 2 electrons in the first level, 8 in the second, 7 in its valence level. All right, when it becomes the chloride ion, we have gained an electron, perhaps from a neutral sodium atom. But because the number of protons in our nucleus stays the same, we have the same level of attraction, the same effective core charge for these valence electrons. But that extra negative is going to cause some extra repulsion. Extra repulsion. We have that added electron, added negative charge, added like charge, no extra positive proton in the nucleus to suck it in. It's going to have some extra repulsion, get a little larger. Boom! And we are done.